Here we are in section 7-3, exercises 1 through 3. It says to graph the following, label the domain and range. Now let's remind ourselves, the domain of a radical square root in particular is that we need to have things under the square root that are greater than or equal to 0. If we put in negatives, the square root of a negative number does not come out anywhere in the real numbers. So square root of a -4 doesn't come out, square root of a -2. So we need to start with whatever's under the square root greater than or equal to 0. And then once we find out where we start, once we start putting in numbers, we start at the smallest, we stick in a 0, we get square root of 0, 0, and then as this increases, the other increases, which helps us to identify our range. Okay, number 1, let's try it. So here, first of all, we're going to find the domain. So the domain happens when whatever's under the square root, x minus 3, is bigger than or equal to 0. We have to make sure that x minus 3 is bigger than or equal to 0 so we can take the square root of positive numbers and 0. This gives us x greater than or equal to 3. Good. Now how do we write that? You could write it as just the domain of that is x greater than or equal to 3. Or remember, the interval notation would be 3 to infinity. And you include 3 this time. Good. And then, yeah, that's good. So what does that mean? Oh, let's do a couple of numbers so we can see what that is. So if we have an x and a y, and we said, okay, if we were to stick in 2, that's not going to get us anything. 3 is going to be okay. 4 and 5 and 6. That'll give us just a couple of numbers to stick in there. So if we stick in 2, 2 minus 3 is -1. Square root of -1, nope, nothing happens there. Stick in 3. 3 minus 3 is 0. Square root of 0 is 0. 4. 4 minus 3 is 1. Square root of 1 is 1. 5. F of 5 would give us square root of 5 minus 3 is 2. Square root of 2 is like 1.4 something. And then, yeah, okay. And then we stick in square root of, 6 minus 3. Square root of 3, that's like 1.7 something. So you can see it just keeps getting bigger and bigger as we pick in bigger numbers. So we start at 3, 0, right there. Oh, let's see, the range just keeps going up higher, so we can put that in here now. The range is a set of all y such that y is bigger than or equal to, notice our smallest number we have is 0 here, which we could have also written as 0 to infinity. And notice that it goes like this, and then 4, 1, and they will all have the same shape as half a parabola shooting off to the right. Okay, let's try the next one. Number 2, the domain. We need to worry about this being greater than or equal to 0, so x is bigger than or equal to 0. Look, it's already solved for it. That's good. So we would write it, set notation, x such that x is bigger than or equal to 0. Good. And we would also write that in interval notation like this, from 0 to infinity, but 0 we can put in, but we never quite hit infinity. All right, let's do a couple of points just so we can see what happens here. I'll try to pick nicer points this time, like better than I did on number 1. So we can stick in, notice if we stick in -1, we won't get anything because it's not in the domain. If we stick in 0, we should get something. And if we stick in 1, or if we stick in, what's a good square root? 4 or 9, we better get something good. Okay, so -1, nope, it's not in the domain. Stick in 0, we get square root of 0 is 0, plus 6 is 6. Stick in 1, square root of 1 is 1, plus 6 is 7. Stick in 4, square root of 4 is 2, plus 6 is 8. Stick in 9, square root of 9 is 3, plus 6 is 9. So you'll notice they just keep getting bigger and bigger, and if we would have picked like 2 or 3 or 5 or 6 or 7, we would have gotten decimals in here. But this gives us enough. If we stick in 0, we get 6. And notice there's nothing over here. If we stick in -1 or -2, square root of -1 is not a real number. It's not on the graph anywhere, so it's not in the domain. So we stick that in, 0, 6, 1, 7, 4, 8, And yeah, it'll have the exact same shape like this. That helps us to see the range starts. This is our smallest number here on the range, and we just keep getting bigger from there. So the range is going to be the set of all y's such that y is bigger than or equal to 6. And that's how you find out, is you go start at that starting point, and that tells you, oh, we started at 6 and we go up from there. We never hit anything below a 6. And we would write that in interval notation like 6 to infinity. And that's with the interval notation right there. Domain, range, and graphed. Excellent. All right. And the final one, number 3. Ooh, this one's a little bit trickier. Here, we have to make x plus 9. So the domain, we have to make the x plus 9 bigger than or equal to 0, which if we solve it, we get x bigger than or equal to negative 9. So that tells us what our domain is. Let's go ahead and put it in official set notation, make it look pretty there. Also written as negative 9 to infinity. All right, so let's get a couple of points out here and we can see what our range is like. So if we stick in negative 10, we're not going to get anything. If we stick in negative 9, we are going to get something. That's what the domain tells us. Negative 8 tells us something like that. What if we stick in like a negative 5? That'll give us something. What if we stick in a negative 9? That'll give us something. All right. Not a negative 9. What am I thinking? Stick in a 0. There we go. Those will be some nice numbers. If you stuck in other numbers, you'll get decimals, and that's all right. So let's stick in negative 10. Negative 10 plus 9 is negative 1. Square root of negative 1 isn't going to give us anything on the graph. Square root of negative 1. Who ever heard of such a thing? All right, so that's negative 10. Doesn't give us anything. Yep, it's not in the domain. Negative 9 is negative 9 plus 9. That's the beginning of our domain and gives us the square root of 0. 2 times 0 is 0 plus 7 is 7. This gives us a hint. Negative 9, 7. This is where our range will start. It's right here. That's the first part of our domain, so that's the edge, so that's where our range will start. We stick in negative 8. Negative 8 plus 9 is positive 1. Square root of 1 is 1. 2 times 1 is 2. Plus 7 is 9. So negative 8 gets up here at 9. Looks a little bit taller like that. Okay, good. Negative 5. Negative 5 plus 9 is 4. That's why I picked it, so it'd come out nice here. Square root of 4 is 2. 2 times 2 is 4, plus 7 is 11. So negative 5 and 11 is about right there. And stick in 0. 0 plus 9 is 9. Square root of 9 is 3. 2 times 3 is 6, plus 7 is 13. So 0, 13. So this is kind of a fatter one going off like that. It's going to head up there again with the same shape, but that 2 caused it to be a little bit wider. And notice that from 7, we just keep getting higher and higher. So the range on this guy is that y is going to start at 7 and just get bigger. So y is greater than or equal to 7. We would also write that as 7 to infinity. That's interval notation. And I think that's what our graph would look like. I think that does it. Excellent.